Welcome back to part 2 of constructing velocity versus time graphs. Again, I was repeat about last thing in part 1. If you haven't seen that, go back to part 1. Now, again, I'm going to talk about how curved lines will go to diagonals. Diagonals go flat. Flat lines will go along the 0-axis. In a displacement graph, if you go down to the velocity graph, that is your slope. So if we can find the slope of a curvy line, which would be very difficult to do, but it would come out as a straight line. If you find the slope of a straight line, it's just going to get a flat line. And a flat line, which has a 0 slope, will automatically make it go to the flat line. Again, going back to the previous video, we need to take this and first segment the line. We need to look at the different portions. We notice it's linear, it breaks here, then it goes curve, goes back to linear here, curves again, and then it has here and it goes flat. So there are 3 segments that we can get the slopes. The curves we cannot. So we're going to put part A, part B, on part C. We're going to pause here for a moment and get those slopes. Welcome back. Now that you've had time to pause the video, look at the slopes, you can determine the slopes that are there. The slopes are going to be negative 3.3 up, or sorry, not a negative, a positive 3.3, a positive 40, and a 0 slope for our final one. Now we move over to our velocity versus time graph. Take a moment and figure out, looking at our lowest numbers to our highest numbers, figure out which units you want to use and write those down. Now that you have your numbers, I decided to go with 5s. 5, 10, 15, 20, 25, 30, 35. And then I had to add an extra little layer for 40. You may have gone with 6s or 7s. That's okay. So we start off with this portion. Time equals 0. It went up at a speed of 3.3. So, and it went out until 6 seconds. So a diagonal line is going to go straight. So it's going to go straight at a speed 3.3 until 6 seconds. At that point, it curves. We're going to skip that curve again, and we're going to go over until time equals 8. At time equals 8, then it has a huge speed of 40. So we're going to skip over to time equals 8, and it went here. But this time, it's again a straight line, a diagonal line. So it's going to be a straight line all the way up here. Again, it goes curvy, but then it goes flat again. This slope has a slope of 0 along the x-axis at time equals 13. So we're going to put a line, very difficult to see along this, but there's a line here. Now our curvy lines, again, connect these 2 points and these 2 points. So we just take a nice ruler and draw a straight line connecting those 2. Now we can look at this and interpret this graph. It's going at a specific constant flat velocity of something underneath about 3.3 meters per second. Then suddenly it hits the gas, speeds up until it reaches 40 miles an hour. Then for a short period of time it continues at that same speed of 40 miles an hour just for a second. And then sees that cop, hits the brakes, slows way down until it comes to a stop, right before Godzilla eats you. So that is the interpretation of the velocity versus time graph. If you have any further questions, go ahead and ask your teacher.